Hi, at least I'm David Chan. This is Colin Tainter. This is Ryan Liu. And we're about to do the first law of thermodynamics. Right, guys?
Yeah.
Alright.
The first law is the change in the internal temperature is equal to the heat added to the system minus the work done by the system.
We're about to measure the normal body temperature of a normal human being, such as myself. Hopefully I'm normal. With this ear scanner thing. It measures the temperature of your body, which should be 98.6. So it is 98.6. So we're good. We use this little hand warmer to try and heat up it, and it said to shake it up about 2 minutes and then keep it in an enclosed environment for about 20. So that's what we'll be doing, and we'll be right back. So 20 minutes later, we kept it in an enclosed environment, and it's feeling pretty hot right now, so let's see how much it is. 107.4 degrees Fahrenheit. Alright, now let's see how that does with my ear. We'll be keeping this in my ear for about 10 minutes? 10 minutes, and see how my body temperature raises. Or my ear temperature at least. So, I've now had this in my ear for, makes it 20 minutes. You hear this beautiful music. Now, we will record how much temperature my ear has been raised. It says 99.2, so that's 0.6 degrees Fahrenheit increased.
Internal temperature was the final temperature minus the initial temperature of David's ear, and that is equal to the hand warmer minus the transfer of heat into David's ear.
Alright, so now we're going to use a freezer pack, an ice pack actually, as Bilu says, and it says that it should reach the temperature of our freezer after an hour, and it's been an hour since we put it in. And the freezer should be at around 15 degrees, so let's test it right now. Uh, 17.7 degrees Fahrenheit, that's pretty accurate. Now we're going to hold this to my ear for about 5 minutes because I can't last 10 minutes with this.
Finish chilling.
So, I had this in my ear for 5 minutes now. And my ear is really cold. And we will now measure how much lower my ear went, and it is 96.9 degrees Fahrenheit. Went
The
down.
change in the internal energy is the final temperature minus the initial temperature, and that is equal to the ice pack, which was the heat added, minus the work done, which was the transfer of heat into David's ear.
So the first law of thermodynamics states that the change in internal energy of a system is equal to the heat added to the system minus the work done on or by the system. For our experiment, the change in internal energy was measured by the change of temperature of David's ear. For the hand warmer, the temperature of David's ear was 98.6 degrees, and it changed to 99.2 degrees. So it was a change of 0.6 degrees. The heat added was from the ice pack, which is at a temperature of 107.4 degrees. And then the work done on the system, David's ear, was the transfer of energy from the hand warmer to David's ear. So the first law of thermodynamics acts as an application of the law of conservation of energy. Any work done must be transferred to some other place.
I learned that the internal heat of a given item is changed by external energy being transferred into it.
Another important thing to know is that putting a hand warmer to your ear for about 10 minutes is probably the smartest idea. Makes your face feel kind of funny. And that putting an ice pack to your ear also makes it seem pretty numb after 5 minutes. So, note to self.